2009, an outbreak of an aggressive new strain of influenza virus caused a serious global pandemic. According to the World Health Organization, this swine flu spread to over 214 countries and territories and was responsible for more than 18,000 deaths worldwide. The virus was identified as H1N1, which describes the tools the virus uses to attach and later detach itself from cells that it infects. Healthcare professionals and researchers in Canada and around the world were quick to notice some unusual statistics during the 2009 flu pandemic. Out of the patients who were hospitalized or died, as much as 40% had asthma, more than any other underlying health condition including diabetes, chronic heart and lung diseases, weakened immune systems, neurological conditions, and more. So what was different about asthmatics that put them at a disadvantage when it came to being infected with H1N1? Was it their drugs? Was it easier for the virus to infect their cells? Was their immune response blunted? Or was it all just a great big coincidence in the first place? In collaboration with a virologist at Simon Fraser University, our team at the UBC Centre for Heart-Lung Innovation designed an experiment to try to understand what was going on. We exposed mice to an extract made from house dust mites to create a model of allergic asthma. We then infected the mice with a strain of H1N1 from one of the first patients in Southern California during the 2009 pandemic. The results were striking. About a week after getting infected with H1N1, the asthmatic mice lost up to 20% of their body weight, indicating a loss of appetite and hydration related to the onset of illness. Meanwhile, the normal mice had earlier peaked at around 15% weight loss and had already begun to recover by then. Our further tests found that the asthmatic mice had a viral load in their lungs that was nearly 7 times higher, while at the same time having less antibodies that would target H1N1 in the lungs and help get rid of it. Needless to say, this is a terrible combo that means asthmatic mice have a harder time mounting a proper immune response to clear the virus and return to health. Now with evidence to suggest the statistics were no coincidence when it came to asthmatics being more prone to negative health outcomes, our next steps are to dive deeper and find out why that would be. We would also like to better understand the antiviral response in human asthmatic patients by looking at how cells lining the upper respiratory tract respond to H1N1 infection. This research would help guide Canadian healthcare providers should another similar pandemic occur. Hopefully our fellow Canadians already dealing with asthma will have one less thing to worry about, and then we can all breathe a little easier.